Okay, so I'm going to start now. First of all, thank you everyone for joining this webinar. And I want to apologize for rescheduling this webinar. I got stuck into a production issue, and you know what happens if you're stuck in a production issue, right? You never know when it's going to finish. So I just finished like 20 minutes back. And thankfully, the issue is now resolved. My application is still live, and then users are still able to access it. Uh, Having said that, I still want to apologize to each and every one of you. I got a couple of messages on LinkedIn as well that people were waiting for the webinar, but we have to reschedule. So it's totally on me. So I want to apologize, and I will try to make sure that after this webinar, you learn something out of it, so that you it was worth it for each and every one of you to wait and then maybe join twice in the same day. So, a little bit about myself. My name is Mohit Chhabra. I work for a company called Media in Gambia. I've been working there since past 1.5 years. I'm situated in Germany. I blog on a site called Azureguy.in, and I'm a Microsoft MVP for Microsoft Azure. So I've been working with Azure since past 7 years, I would say. So I started working on Azure when I was a student, and since then it's been my first love. And today I'm going to talk about Azure CosmosDB Graph API. So we are going to see that how can we use Graph API in the Azure CosmosDB. But few of you might be thinking that the title said that okay, how we can use the free tier. So yes, we are going to talk about that as well. That how of what options is provided in the free tier now. The free tier has been included recently. I think it's around 3 weeks that Microsoft has announced it, and uh, and I think it's quite useful to get that free tier to test out your applications or to test out some business scenarios or just play around. Uh, so we are going to look into that. So let's go to the session. So I basically will make sure that by the end of this session you have a if not Cosmos CV at least NoSQL written into your resume. So a lot of people says that if you know NoSQL, that is NoSQL. Uh, so what does NoSQL means? NoSQL is basically not only SQL. So what is the difference between SQL and NoSQL? So a lot of people have been confused in these terms, and there is a debate in the market right now that whether we should go with SQL or NoSQL. And so a lot of people who ask me, I'm building an application, whether should I use a SQL database or a NoSQL? So I say it depends. So there is no solution, there is no magic wand that you can use to solve all your programs, but it depends upon the program, the type of program you're trying to solve. I am personally a bigger fan of NoSQL as compared to SQL, but we all started learning about SQL when we were in school, colleges. So this technology has been there since decades now, and it has proven itself to be a solid database model for high enterprise level applications. Having said that, I just want to clarify one more thing. When I am going to say SQL throughout this webinar, I don't only mean SQL Server. I mean SQL-based database, whether it's Oracle as well or MySQL as well. So don't get confused between SQL and SQL Server. So this will SQL Server as well as the MySQL as and Oracle-based database as well. So SQL-based database is basically built on the phenomena of RDBMS. I hope all of you understand what is RDBMS. Uh, Whereas NoSQL is built on non-relational data. So what does this mean? This means that in the SQL world, we need to have a fixed schema. We need to have a schema defined. We need to have a relationship models defined between our entities. Whereas in a NoSQL world, we don't have any sort of relations between our entities. Uh, what does this mean? This okay? I have relations or not relations. So let me give you an example. So in a SQL world, we basically put everything in sort of tables. Then we have multiple tables. For example, employee table. Now we can have another table called spouse table, and then another table called kids table. So and these tables are basically interrelated. And then we basically, if you want to have a, if you want to search for a result, that give me the name of the users and their spouse and their kids, then basically I have to make a join or run a query which basically gets the data from all three tables and serve it to me. So we have to build our relationships between this sort of system, right, in this RDBMS model. Whereas in a NoSQL kind of database, the whole record all of a of an entity basically is kept together in one form. For example, whether a user has an employee has basically a spouse or not, or kid or not. So those one will be part of one record. We don't have to go to another records or another table basically to get that data. All of the data related to one entity is kept together. For example, let's take another example. Uh, we had a fixed requirement. We created a SQL based database. And then what happened is we got another requirement from client to add a new feature or a new column, as simple as adding a spouse column in our database. Now, what will happen? Like I am a bachelor, so I don't have a spouse. And when I say I don't have a spouse, so that means the value of that is no for me, maybe. But all the people who were already present in that database, we have to alter their tables as well. Why do we have to alter their tables? Because we're adding a new column into our database, and we don't have the values, necessary values that we have to put for those existing users, because our business requirement change over time. Now we have to use alter table commands to alter that table, and then maybe put some null values or default values for those fields, for those all the entities that are already present in the database. Whereas when it comes to NoSQL basically, that because it doesn't have a fixed schema, it gives you a flexibility of adding any number of properties to an individual. As I gave you an example that I don't have a spouse, I don't have a kid as well. So those are properties are not related to me. Whereas if I have a colleague who is married and who has children, those are properties will be related to that person. So we have identified over a period of time that the data is difficult to be structured, and it's difficult to maintain a structured data. So that's why we went ahead, and then there was a need of building a NoSQL based database, or in another words, it's there was a need of building a unstructured database. So uh, in a SQL world, we basically scale up. Whereas in a NoSQL world, we mostly scale out. What does this mean? Scale up and scale out means we increase the capacity of the server in a SQL-based database, whereas we can have a distributed database in a NoSQL scenario, where because all the records, all the data associated with one particular record is kept together. It doesn't matter basically how many, if you have a multiple servers, multiple instances of one server scenario. In a in a SQL world, we have atomic transitions. What is atomic? Atomic, if you remember, we used to talk about acid transitions. What is was acid? Acid basically has A in it, which means atomic transitions. Atomic means it's either all or nothing. Either the records are going to get in or not, and it has to be consistent. So these are like important in a financial based application, because if you are dealing with a banking application, so finance based application where there is money involved and the transitions related to money involved, you have to make sure that the data basically is consistent across your servers. Secondly, it's immediately reflected. Whereas when it comes to a NoSQL scenario, it has a different consistency level, but the minimalistic consistency level that it offers is eventual consistency. What does this mean? Eventual consistency means eventually the data will be consistent across all the servers, but not immediately. So SQL, I would say, is difficult for programmers, whereas NoSQL is easy for programmers. Why SQL is difficult for programmers? Most of the people might be wondering right now that SQL was something that I used to understand, and SQL was something that I used to understand, but uh, now I'm saying that SQL is difficult for programmers. SQL is basically difficult for programmers because we have to know the relationships upfront and design or write our code in such a manner. Whereas NoSQL gives us the flexibility of changing our code without worrying about how we are going to manage the old records. It gives the business the agility and the flexibility to add or edit or do any changes to your business logic, to your database, to your entities. Let's take an example. In a SQL world, what will happen is basically, let's take an example of a car. So in a SQL world, your car would be disassembled, your steering, all of the steerings would be kept at one place, and all of the seats would be kept at one place, all of the engines would be kept at one place, and all of the brakes would be kept at one place. Whereas, what will happen whenever you want to drive the car, you basically will say, okay, select star from, or not star, select my steering from steerings, join, get me the engine from my engine tables, and then get me the brakes from my brake, and then you assemble it on a fly and then use. Whereas when you compare it to a NoSQL, NoSQL is basically you have the whole car at one place, all the things that were related to that entity. In our scenario, it's a car. All the properties, all the values that were related to the car was kept together because this car is stored in a single relation form. So it was not disassembled like in a SQL way. So there are basically four kind of database. First of them is basically document based. What is document based? Document based means it stores the data in the form of documents. Uh, that means all of the data will be stored in all the data related to one entity is stored in one document for you. The examples of this is basically document DB, MongoDB, Cassandra, and all. The second type of database that is basically graph-based database, and today we are going to talk more about this in detail. So the examples for this is Neo4j, SAP HANA, or Gremlin, and this is what we are going to use in our Cosmos DB account. The third type of database of NoSQL database is key value pair. It's sort of a dictionary kind of value where there is a key and it will query a key and the value associated with it. The simplest example of this is Redis cache or Azure storage, table storage basically. The fourth kind of database is column-based database. In this, instead of row, your main data is basically stored in the form of columns, and then you query the columns instead of rows. So one of them example, it's basically quite good when you're doing some sort of indexing and searching. some sort of the example for this is Cassandra. So talking about Azure Cosmos DB, I hope you all of you understood or have some idea now what is basically the whole concept of NoSQL, why there is a buzz in the market about NoSQL. But today we are going to talk about Cosmos DB in particular. So what is Cosmos DB? Cosmos DB is basically an offering from Microsoft Azure. It's a NoSQL database offering from Microsoft, which gives you much more capabilities than just holding your database. What does it mean? It means that it gives you a global distribution scenario. That means you can replicate your data across multiple regions by just automatically or just a single click buttons. So it's basically gives you the capability to build a multi-distributed application. What is a distributed application? That means if your users are present in multiple countries, for example, if some of your users are in India and some of your users are in US, in that scenario, you don't want to keep your database in only US or only India. Why? Because there would be a network latency to query your database if you have kept it in India and you are querying it from US, and your users are basically accessing it from US, right? So it would be a additional second, but when it comes to performance, I personally think it's that the only thing worse than no internet is slow internet, and similarly, the only thing worse than uh, no application is a slow application. So as a developer, we have to make sure that our applications are performant. Uh, so it gives us the capability, inbuilt capability of replicating your data across multiple regions with, without writing any single piece of code for that. It also gives us the capability of scaling out. And that means we can serve from 1,000 users to 10,000 users to 1 million users in a day. I will give you an idea. One of my applications that I built as a student, I didn't thought it's going to go viral or bit. I didn't even thought that I will get like 1,000 downloads. To be honest, it went viral, and all of a sudden the kind of servers I took was not enough for that application. So we needed the power of cloud. And by the power of cloud, I was able to scale up it in few minutes. And that is what is given to our database as well. So our application doesn't need to scale up only, it's the database as well that needs to scale up. Because if our application is scaled up, for example, but our database is still throttling, that means your database is still not able to serve all the requests that is getting to it, or it's taking a lot of time to serve all those requests. Still, your application is going to be lag, or your application is going to be slow. So the user experience around your application would be bad. And to avoid that, we don't have to scale out only your applications server, but also your database tier as well. So it gives you an inbuilt capability of scaling out. I told you about latency, and it gives you the guaranteed low latency. It also have 5 consistency models. We are going to come to that when we go to the portal. I'm going to show you what are the different consistency model across the multiple offerings of Azure Cosmos DB. And of course, it gives you comprehensive SLAs, which means that it's going to be up for 99.99999%, and so on. And so you don't have to worry about putting your enterprise-based applications on it. This service will be taken care of by Microsoft. You just have to take care of your database. So, as I told you, there are 4 kind of NoSQL database, and all 4 of them basically are supported in Azure Cosmos DB. We have to talk about this consistency level, but we are going to talk once we move to the demo part. So most of the people basically think when they hear the word graph, we have this misconception of what is a graph. If you see on the left hand side of the screen, when we hear the word graph, these are the images that come to our mind. But make no mistake, this is not graph. These are basically charts. Whereas what is a graph? Graph is something that is on your right hand side. Graph is basically a nodes and the vertices assigned to it. So what is a node? A node is basically an entity which can have one or more edges. Now, what is edges? Edges is basically something that connects two nodes. Okay. Uh, I hope you are not able to understand this. And that's completely okay. We have to see what does it means. But just think of these two terminologies for now: node and edges. These are the core terminologies that you should know to go ahead. Graph is nothing but a connected data. So, for example, I'm going to go with an example in this. So, example, n loves 10. So, n is here is a node. N is an entity. N is a node here in this example. Whereas so is Dan. What is the relationship between and Dan? That N loves Dan. So this is the relationship between two entities. So this N is a node, and this is also a node, and these are the edges. So this is how you define a very basic uh, structure in a graph. So relationships here are bidirectional. If N loves Dan, that means Dan also loves N. Although it's not true for all the cases, we have one-sided lovers as well. But in this scenario, let's say they are in relationships. So if they're in a relationship, we assume that both of them love each other. So relationships are basically directional. So that means if Anne loves Dan, that doesn't mean that Dan loves Anne as well. So we point it out by specifying this arrow. If you see on the screen, we have a bidirectional arrow on that means to define the relationship. So if you see now Dan, Anne basically has some properties assigned to her. What are the properties? Her name is Anne. She was born on 29th in 1970. Her Twitter handle is @Anne. And the relationship that she shares with Dan is basically that she loves and they loves that. We already discussed about that part. But if you see over here Dan doesn't have all the properties that Anne has. See, Dan has only name and date of birth, but not a Twitter handle assigned to him. Maybe he doesn't own a Twitter handle, so that information is not present. But our schema, because it's a NoSQL, we don't have to worry about that. Some of these people who might be coming from a SQL world might be feeling uncomfortable already, but this property just because this property does not apply to Dan, we don't even mention it. Now, the another relationship is with this car. Now, this car is another node for us. What is the relationship? That she and drives that car, and then also drives that car. But there is one more relationship that Dan owns uh, this car, but she doesn't own this car. That means this is another node, and this is a person. A node can have multiple relationship with another node. So in this scenario, Dan has two relationships: drives and own. And the properties associated with that relationship is in this scenario is he owns that car since January 10, 2011, whereas she is driving this car from January 10, 2011. So these are the properties associated with this relationship. Now think of this. We basically label this as we can label our nodes. How do we label? We say, okay, this is a person type. Both of them and then are labeled as person. Whereas the car is labeled as car or vehicle or both. So if we query that, okay, I need all the persons, the people who have been labeled with persons will come up and not this relationship. Because we might have a query where you say that show me all the relations that Dan has. So in this scenario, you don't have to basically find out the Dan's relationship with the vehicle. You only want to find out relationship Dan has with uh, persons. So you will only query on this person label instead of querying it on vehicle or car label. Now, if we think of it in the English language, if we try to map it in the English language, uh, the labels will be nothing but nouns. The and your nodes will be nothing but nouns. The relationship will be nothing but a verb, whereas the properties associated with that person uh, would be the adjective, and the properties associated with the verb would be adverbs. I know most of you have learned English actually from Netflix, including me, instead of Ven and Martin. So this might be confusing to you. I will go back to one slide and then try to recap myself. So if you see this guy, a node is basically a noun, whereas the properties associated with it is adjective. The relationship defined can be defined as a verb, whereas the properties associated with that relationship can be defined as adverbs in English language. I hope this makes sense to you somehow, and I'm going to go ahead. If you still had any doubt, feel free to ask questions in the comments, and I will be happy to answer after this session. So we talk about different components. So we said that okay, it can have a name value pair. It can basically can be labeled. This relationship can be type, and it can be directional. And it only can have a name value properties. So we said okay, this graph is one said. Uh, Most of the people when I talk about graph, they think that graph is only utilized in a social network way. I think graph is heavily utilized in a social network kind of applications. For example, if you have seen features on Facebook like people you may know, it suggests you the people that you might have already interacted or you have some mutual friends. So how does it decide that? Or if you go to LinkedIn, it shows you a feature that okay, this person can be introduce you to 28 people in IBM. So how does it define that this person has 28 can introduce me to 28 people at IBM? In that scenario, I will be one node. I am connected to, for example, Kasam. I'm connected to Kasam on LinkedIn. So that is, I share a relationship with Kasam of connection. Then Kasam is was let's say Kasam is working in IBM. So in this scenario, he has 28 more friends of his who are working in IBM, and he knows 28 more people who are again different nodes now, and IBM is also one node. So if I have to connect between all these nodes, and if I try to make a connection from myself to IBM, then this is how they traverse the graph from me to Kasam to 28 connections, and then IBM. This is how it traverses and say, okay, uh, Kasam can introduce you to 28 people in IBM. But this is one of the most common use case of it, but not the only use case of it. Another example that you all of you must have seen that in your social network like Facebook, you get the friends relation like you have 50 mutual friends. How do they define that you have those number of mutual friends? You see that okay, you are one node and that person is one node, and then you see how many people are connected to you both. So we will query for relationships. I am a friend with XYZ, so that person is my friend. That XYZ is also friend of this. So now both of us shares a friendship relation with this XYZ. We will search for these and then find out that how many people have the same relationship, and then we find out okay, this is the number of mutual connections that we have, and hence the AI kicks in and it recommends you the people that you may know. But as I said, social network is one of the most common use case of it, but not the only use case of it. So where else it can be used? It can be basically used in building a real-time recommendation-based system. It can be used to say, okay, people who bought this also bought this. We all have seen this in Amazon or Flipkart, right? That people bought this, also bought this, they view this. So this is how it's defined. So one entity is one node here, and one individual is also one node. We have two relationships. She bought, but she viewed this as well. Where this guy bought and viewed this, and this guy bought and viewed this, and this is how the relationship. So this guy with the beard bought a bucket as well as the instrument, right? So this is how you define that the relationships, and then you basically query it. How many people are basically buying the things together or viewing the things together? So you try to define a pattern and put it to AI so that basically your AI can learn from that pattern and give more better recommendations to your users. Second scenario is master data management. That means in your companies how the hierarchies are not always in a hierarchical manner. It can be complex, but how two people are connected to each other. And here in this scenario, this person manages another lady, and then she manages another people, but those people manages another person. So the whole scenario in this case is complex. So you cannot just define it in a hierarchy way, but you basically define it with relationships. The another is fraud detection. Fraud detection, what it does is basically it tells you that okay, if I owns an account in a bank and my brother had done some fraud in the past in some another bank and he didn't paid his credit card bills, and I'm going to take a loan, uh, that there is a high chance, or if I already have taken a loan from another bank, there is a high chance that I'm not going to pay off the loan that I'm going to take now. Or basically similarly, it can be used for insurance purposes as well. So only if our banks have used it for Vijay Maria or Neva Modi, we would be in a better situation right now, but unfortunately they didn't. But we are the developers, so we have to make sure that we use the technology in such a way that it takes to the next level and secure your businesses and applications. So it's also basically used for searching because again everything is not just an entity; it has a relationship. The whole concept of graph based database also started because we needed to search in a better way. I cannot say that books, I can say that reads. I need something for reading, and then still the books should come up. Or I need something for writing, and then the pen or the pencil should come up. So we needed to search not on the entities but also on the relations associated with that or the properties associated with that. It's highly used in basically in managing the identity and access system. One user uh, can be part of multiple domains, multiple groups, multiple OUs. So it's difficult to just identify them as single user and then managing it. But the management of whole the systems or finding the whole systems can be done via graph databases. So this was again the basic of NoSQL and graph. Today, there was we will talk about Gremlin, which because Gremlin is the API which is supported in Cosmos DB. So nothing specific about Gremlin. It's basically native to Java and Groovy, but it's with C Sharp as well. It's highly supported, or it's supported with multiple languages. When it comes to Cosmos DB give you a wrapper around it, so you have a full-blown SDK that you can use to use this database. Just a quick go through of the difference of how you're going to query. So in our SQL word, we used to say that select star from users. Here instead we say graph, we use G for graph and say dot V for vertices. What vertices you want to find of type, which type, user, and then map it. Similarly, if you want to get all the usernames, we just search for the user and then the name property of it. Map here is a function if you see, or the developer should be able to understand this is the function where this is the property associated with the values. Similarly, if you want to search for select name images, we do select name age from users. Now we basically say type users and transform the name and get it the property of name, age, and get the property of age. So the people who are not who have been familiar with SQL, they might be finding it difficult to see this queries. But trust me, once you are familiar with this and you spend some time, it's easier to write these kind of queries instead of writing a SQL, because if it's a saying that if you can draw it on a piece of paper or a chalkboard or a whiteboard, basically you can write the query for it in a graph-based database. Similarly, if you want to find the oldest user, you say select maximum age. Here you say that okay, type user again. We take the age property of it and then use the maximum function inbuilt function to get the maximum out of it. So enough with the theory. Let's talk and see some demo. So I'm giving you 30 seconds to basically take a screenshot or scan it in your phones and download the code, and maybe you can play it around little, fork it. It's nothing fancy, but it's going to give you a high level idea of how basically government or we as an individual can build potential COVID-19 patient tracker. So we see that, okay, how we can use this graph database to identify people who might be affected with COVID-19. So I'm for 10 seconds before I take the screen out. I hope all of you were able to grab the URL or take the pictures of it. So I'm going to take it out and we'll move away from the presentation and we'll go to the code part, because we as developers like to code instead of going through PPT. So what I have done, I have already uh, a Cosmos DB account, and then I've created this code. It still has all the in my GitHub account as well. It still has all the credentials because I just uploaded it a couple of minutes before the session started, and I'm going to delete this Cosmos DB account right after this session. So don't even try to use this or steal my database. So now, before I go into the code, I want to go to the portal and tell you how do you create a Cosmos DB account and what all information do you need. If you see here, you have some auth key, some database value, some collections, and a host name. From where I got this information, and from where I basically how you can get this information. So I will go to portal.azure.com. I will go to the right account. So I will search for Cosmos DB and I will create a Cosmos DB account. So I'm going to create a new resource group for the people who are not familiar with Azure. So resource group is nothing but a logical container which holds all your resources together in a one group, in a one container. They may or may not be in the same geographical locations, but it's ideal to put all the resources of one application in one resource group. So I'm going to name it Azure Cosmos Demo so that I can delete it later. So you basically put a meaningful name to your resource group so you can identify what is a name, maybe under the name of the application that you're using it, that infrastructure for. Mm, such a long name, but it's okay. Now, if you see here, we have different APIs that is supported here. And today we are going to use not MongoDB, not DocumentDB, not Cassandra, not Table, but we are going to use something called Gremlin or the Graph API. Now we have to basically select in the region. So I will look for the nearest region. I will just next to Switzerland. So I should use Switzerland. The account type, I'm going to use it for non-production. I don't need geo redundancy because it's a test network for me, and it gives me the multi-region rights as well. So it says that it's going to take 11 minutes for the people who have making this for the first time. They will see an option here. Oops. They will see an option here to use the free tier over here. Just because I have multiple options, I'm no longer seeing it. But for the people, if you are trying it for the first time in your subscriptions, you will see to the option of using the free tier of it. And I'm going to talk about what is this free tier. So let me say as your demo real quick. This works. Uh, Cosmos demo SQL webinar. No SQL, no SQL. Okay, let me again choose Gremlin and then Switzerland. Now you can put this Cosmos DB as a part of your network. You can have a private endpoint or a public endpoint associated with it and make it as a part of one virtual network. So only the limited servers can access it, or you can have a public endpoint with certain networks as well. So right now I'm just make it public. because it's just a test environment. So I'm going to quickly create it. But as you see that the number of minutes that it says, it's going to be more than 10. It said that it's going to take 11 minutes to do this deployment. Hopefully it will be completed before that, but normally database takes some of time. So we are basically going to use this uh, as a cookie show. If you've seen cookie shows, what happens in the cookie show, the the chef basically puts something in the oven, and he already has prepared the another next version of it and shows it to you. Okay, this is how it will look after 30 minutes of baking. So we are going to go with that route itself. And I already created something yesterday, or I think day before yesterday. Uh, so I'm going to go with that account. This is again the same. The one thing that you have to understand here is I have created uh, vetted road. So this is my graph DB database, and inside that I've created this uh, database collection. So if I wrote this graph, I have some data already in it. So what we are going to do, we are going to clean this data before we put our code. But we talk about we were supposed to talk about replication. So I told you about that you can replicate your data across multiple regions. So it's as simple as just clicking on this button and your data will be replicated automatically. And we also talk about consistency level. So if you see that the screen right now, strong means strong. The consistency across multiple regions would be strong, and it will be same, and at the same time the changes are happening, it will be replicated immediately across multiple regions. So if you see here, this is the bounded stillness. Here you can say maximum time what can is possible for your applications. It's okay for your business scenario to that. And if you see, if someone writes on Switzerland in North, it's immediately it's available for read, but it's after some seconds it's available for read in Australia Center, and then but immediately or some seconds after that it's available in Australia East as well. So this number of seconds you can define it in your over here. Session, as the name suggests, session is consistent for one session. That means if you see here in A writes in session one, and in session the read is immediately updated in session A, because and even the same in different reason. But if they are in the same session, it's immediately replicated. But in session B, it's not immediately replicated. So consistent prefix. Uh, so it means that if you basically perform something in a sequence, it will basically go in the same order. It can take still some time, but the order would be maintained. Whereas the eventual means that, as the name suggests, eventually every region or every version of it would be reflected or would be updated, but not immediately. So this eventually is good for social media kind of application, but this strong is basically recommended for financial kind of applications, or which all basically if you're using it for maintaining the stock. So if you only have one stock, and if I've already bought it, it should not show to the user in the front region. Right. So coming to the demo, if you see, the first thing that we are doing is we are dropping the database. and then I'm basically adding few vertices and adding some edges. So first I'm adding so before I go there, let me show you how what is this code. So I have added some basic information of this database. So this is the database key and the database name and the collection associated with it. But our code, I what I'm doing is basically I'm making this a Gremlin, a new instance of a Gremlin server, which is using this information to build a URL for me. And this server is nothing that the account that we just now created in Azure portal. Then I'm basically creating a client, and then from that client, I am basically taking all the queries over here. I'm building this Gremlin queries, and then I'm basically what I'm doing is I'm using this query and putting it in the submit request. So if I go to the submit request, what it does is just take this client and submit this query, whatever query we have into the database. So what queries we are building? We are adding a person called Thomas, with his first name as Thomas and his property as age is 44, and similarly for Mary. And we are adding her last name as well, because as I told you, a NoSQL database can have different properties for different entities. Similarly, then we have added Ben. Similarly, we added Robin, and now how they are connected. So I've added 8 different people over here with some properties defined to them. Now I've added how they are connected. So we say add edge. Remember we talked about vertices and edge. We talked about nodes and edge. So this is how they're connected. So at Thomas is basically colleague of Mary, and Thomas is also colleague of Ben, whereas Ben is colleague of Robin, and Nick and Ben is basically husband of Nikki, and Nikki is the mother of Eric. So this is how you build the relationship. Let me run this code. So if you see, it dropped the database. It dropped the database first, and then we added all of them one by one. So you got 200, you got 200, you got multiple 200s for all the queries that we have built. And because we run it in a for each loop and then edit it individually, it basically made multiple calls to the database and then added those queries. So if I go back to the portal and go to the Data Explorer over here, let me zoom in. So we say that Alex is one node and Nikki is one. How Nikki is connected? We say that Nikki is a mother of Alex. Now Nikki is connected to different people. Nikki is connected to Ben, and what are the relationship they share? Ben is a colleague. Ben is the husband of Nikki, and Ben is connected to again multiple people. Ben is connected to Robin. For my connections grows, so I have to refresh it. Okay, let me refresh. I think I zoomed too much. Let me close this and then rerun the query. We try to reload the graph. So now we were talking about some individuals. So these people are again connected to each other. How they are connected is their colleagues. So the title of the demo said that okay, how we can track a potential COVID-19 patient, right? So uh, let's say Alex got infected. We know that Alex got infected. Now we know that Alex has a relationship with Nikki, right? So there is a high chance that Nikki will be affected as well because they share a relationship of mother and son. Now Nikki afterwards was connected to Ben as well, so they have a high chances of getting this infection again. Now how Ben is connected. Ben is connected to multiple people. He's connected to Thomas. He's connected to Robin, and they are also connected. So if you are able to trace this chain, this is how you are tracing the chain. You might have been hearing this word in the news quite often now that you track the chain and then basically stop the chain. This is how you basically track the chain. You track the chain. Okay, these people have some relationship or they met these people. So we then test all of these people or put them in quarantine. And then if this guy doesn't have symptoms for 14 days, that means this Ben has not transferred to Thomas, but Ben might have transferred this infection to Robin. Then we'll basically go ahead and check all the people who are connected to Robin, the wife of Robin, their kids or colleagues or neighbors. So this is how you build a system where you can connect the dots and then identify the relationships in an application. This is how we say okay. We want to break the chain. We want to break the chain because every individuals are connected to each other, and this is how we identify whether this person might have infection or not. So now all this computing basically needs some sort of server power. So we use something called throughput. So it's always difficult to identify how much throughput does your application need. But you can set your application to use throughput of 400 RUs. RUs is nothing but reserved units. And 5 GB of database and 400 RUs is free for you for the lifetime. That means if you go beyond 400 and you allow it to scale, if there is a spike, it will go up, it will serve your request, but the moment it comes down, uh, it's free. So you only pay for that spike that you are there is a scale up. Also, for a property of lifetime, you have a database of 5 GB for free. So if it exceeds your data exceeds 5 GB, then you are basically trying to build an application that might be giving some money to you. So Microsoft basically will charge you for that application. I hope you understood the whole concept of the difference between SQL and NoSQL. What are the different types of NoSQL databases we had? We then discuss what is graph in specific. How do we define edges, vertices, and nodes? Then we talk about how we basically can build our own application and put some data to the cloud. We created an account, we updated the values, and then I talk about how this technology can be utilized to identify a patient or a potential patient. So that's it from my side for this webinar. I am now open for questions.